Hello class, welcome to PreAlgebra. This is chapter 1.9. Today we're talking about division. Now I'm sure most of you already know how to do basic division, something along the lines of, let's say, 10 divided by 3, or something easier, let me use a 10 divided by 2, right? You might say to yourself, okay, 10 divided by 2 is simple, that's 5, right? Because 5 multiplied by 2 would give you 10, right? Now, if you're looking at this visually, you might say to yourself, look, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Skittles, and I need to divide them into 2 bags, right? How many Skittles would I put in each bag? Well, there's 1 bag, there's 2 bags. This is literally 10 split into or divided into 2 bags would give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would give you 5 Skittles in each bag, right? 10 divided by 2 is 5. 5 times 2 is 10. All right, so we're clear on that. What we're doing today is we are going to be talking about long division, right? And long division is the same basic principle. You're trying to take a group and split them in, or trying to take a whole bunch of individuals and split them into groups, right? And each group will have an equal number of items or individuals. So I might have something that looks like this. I might have a 4 on the outside, this brace here, which is the division symbol, and the number, and the number 13, right? So basically we need to know some terminologies. The number that is doing the dividing we call the divisor. It's the one that does the dividing. That's the action, right? The one that is getting divided or split up is called the dividend. I like to remember it as the divided. It is the group that is getting split up, right? So this would be 13 Skittles separated into 4 cups, right? The divisor would be the cups, or the groups, and the 13, whatever the numbers in the inside, will be the individuals. And the way we say this is 13 divided by 4, or 13 split into 4 groups. And the question is, how many in each group? How many in each group? And remember, groups need to be equal. So basically, it's a simple system. What I do is I start with this number, and I say, okay, how many times does it fit? How many of these 4s of the outside numbers can I fit into the inside number? Well, as you know, I cannot fit 4 of anything into 1 of anything. And by that I mean, let's say it's 4 Skittles. I can't fit 4 Skittles into 1, right? There's no way. So 4 does not go into 1. It's 0 times, and then I multiply whatever is on the top by this side number, and I bring that product down here. So 0 times 4 is 0. Then I'm going to subtract whatever's over here, the whole thing, and I'm going to get 1 minus 0, which is 1. And then I'm going to drop this next number, the next digit, and I'm right back to how many 4s fit inside of a 13. Well, if I know my math facts, I know that 4 times 1 is 4. 4 times 2 is 8. Okay, I'm getting closer. 4 times 3 is 12. That's almost there. Let's see, one more. 4 times 4, is 16. So I can't go over, so this one's out. But I can go right underneath it, right? And put 4 times 3. So how many sets of 4 can I fit inside a 12? Well, or I can fit 3, right? And since 12 is the closest number to 13, I could say 4 fits into 13 3 times. 3 times 4 is 12. I put that number down here. Let me put it in red to keep it consistent. 13 minus 12 is 1. There is no more number to bring down, so that is the end. And I say this is my remainder. The way you spell remainder is R-E-M-A-I-N-D-E-R. Remainder 1, right? Or we can say R1. So the answer is 3, and you'll have a remainder of 1 by itself. Okay? We call this answer, in every division problem, the answer is called the quotient. Q-U-O-T-I-E-N-T, the quotient. And that's the answer to a division problem. Okay? So 3 remainder 1 is the answer to what is 13 divided by 4. Now if you don't believe me, take a look at this picture. Let's say I had 13 Skittles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I wanted to divide them into 4 equal groups. Well, I might say to myself, okay, watch this. Let's say this one's going 1, 2, and let's make it a nice easy color, 3. There are my 3 groups, or my 4 groups, right? Sorry, I need one more to make it 13 divided into 4 groups, right? So you're going to have this first one go here, then this one's going here, this one's going here, this one's going here, this one's going here, this one's going here. Remember, I have to make everything equal. This one's going here, 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 this one's going here. Now take a look. All of these cups now have 3 in them, right? But look, there's 1 left. So the question is, if I have 13 items divided into 4 groups, how many of those items would be in each group? Well, you would have 3 items in each group, and you're just going to have a remainder of 1, right? So it's going to be 3 with a remainder of 1, just like we proved here. 3, remainder 1, and that, like we said, is your quotient. All right, let's try another one. Let's try another problem. I'm just going to check. Okay. Let's try a larger number, like 23, and it's going to divide the number 687. 687. How many times can I fit a group of 23 into the number 687? All right, so this is going to require a little bit more thinking. I'm going to say to myself, first, this number we call the divisor, the one that's doing the dividing. We call this number, not the quotient, but the dividend, the one that's being divided. Let me focus on that. So the question is, how many times does 23 fit inside 687? So I'm going to do the same exact thing. I'm going to say, how many 23s, groups of 23s, can I fit inside a 68? Well, let's see. If I do my multiplication facts, I'm going to get 23 times 1 is 23. I can do a little bit more. 23 times 2 is what? I don't know. Times 2, 6, 2 times 3 is 6, 2 times 2 is 4. 46, okay, I can do a little bit more, I think. Let's see 23 times 3. What is that? 3 times 3, 9. 3 times 2, 69. Oh, I was so close. I went over. So I can't use that, but I can use 23 goes into 46 2 times, or twice. So what I'm going to do is I'm going to use this last digit in the ones place, and I'm going to put this number here, because I'm talking about the number 68, right? How many 23s fit inside a 68? Well, 2 times 23 would give us 46. So I'm going to do my process. Now I'm going to subtract this number. I'm going to say 8 minus 6 is what? 2. 6 minus 4 is 2. And remember, I have to drop this last number every time. So now the question is, how many times does 23 fit inside 227? All right, I'm still going to have to do some math here. So let's see. I can't do the same trick I used in the beginning. I have to now try the whole thing. So how many times does 23 go into 227? Let's keep doing our math over here. We know 223 times 3 is 69. 23 times 4 is, let me just add another, 4 times 3 is 12. 4 times 2 is 6. 6 plus 1 is 7. 72, not there yet. 23 times, well, I know I can do 72 twice, because that would be times 8. Let's see if we can skip some stuff. Let's see, so 72 twice. 2, 2, 4, 7, 7, 14, 144. Oh boy, I still have quite a ways to go. It's not 8 times. It might be 9 times. Let's see. 23 times 9. 9 times 3 is 27. 9 times 2 is 18. 18, 19, 20. 207. I think that's as close as we're going to get. Because if I do more, I'd go over to 230. So 23 fits inside 227 9 times. So 9 times 23 is 207. I subtract. 7 minus 7 is 0. 2 minus 0 is 2. 2 minus 2 is 0. Okay, so I got an ender of 20, right? And I clearly cannot fit a 23 inside a group of 20. So my answer is 29 with the remainder, this leftover, of 20. So my quotient is 29, remainder, big R, 20. And that is the answer to what is 687 divided by 23. 29, remainder 20. Eventually you'll get into decimals, but we're not doing that right now. So let's do one more problem. Let's try, oh, here's a good one. 61, and we're going to divide that and find out how many groups of 61 fit inside 1,339. All right, step 1. Can I fit this number inside that? Inside a 1? No, I can't. So I assume there's a 0 up there. Can I fit it inside 13? 1 and 3? Nope. 61 was way too big. So then I try again. Can I fit inside 133? Yes, yes I can. The question is, how many times? Well, let's see. I don't know my 61 multiplication table, so let's see. 61 times 1 gives me 61. This dot also means multiplication, just a faster way of writing it. 61 times 2 equals, I don't know what 61 twice is. 2, 6 times 2, 12, 122. That's as close as we're going to get, because 61 times 3 is 3 times 1, 3. 6 times 3 is 18. 183, which is too high. We're looking for something under 133, and we found 22. So, how many times does 61 go into 133? It's 2 times. Then I multiply 2 times 61, and I put it underneath. Let me erase this to give us space. So 2 times 61 we found out was 122. I line up my place values. Now I subtract, as is the case. 3 minus 2 is 1. 3 minus 2 is 1. 1 minus 1 is 0. Remember to drop the outside number after you've subtracted. The question is now, how many times does 61 fit into 119? Well, it's very clearly not twice, because that's at 122. It's once, right? It can only fit one group of 61 inside it. So 1 times 61 is 61. I put it at the bottom. Then I say 9 minus 1 is 8. Then I say 11 minus 6, because I'm going to borrow 1 anyway. 11 minus 6 is what? 5. Can I fit a 61 inside a 58? No. Is there any numbers to drop down here? No. There's no decimals to deal with, so that's my answer. 21, remainder 58. And I'll have 58 left over. 21 with a remainder of 58. So basically what I've asked is, imagine you have 1,339 Skittles. And I want you to evenly distribute those Skittles into 61 cups. How many Skittles would be in each cup? Well, in the 61 cups, you would have 21 Skittles in each cup, right? So all the cups would have 61 Skittles. And then on the outside, because we don't have enough for a cup, we would have 58 Skittles that didn't make it. And that's what you call your remainder. And they're just on the counter. So 61, you'd have, I'm sorry, you would not have 61 inside. You would have 61 cups. You would have 61 cups, right? And in each of those 61 cups, you would have 21 Skittles. I'm sorry about that. So you would have 61 cups, and then you would have 21 Skittles in each of those cups. And on the outside, on the floor, you would just have 58 Skittles, and that is your remainder. Okay, today you learned about dividing. You've learned about the word divisor, quotient, dividend, and remainder. Good luck with lesson 1.9.